Hello, my name is Ben Wagner. I'm the lead operations section chief for Northern Rockies Team 6. And this morning I want to share with you a more in-depth look at our enduring strategy with a special focus on the Isabel Lake area. We define our strategy on Team 6 by starting with what a successful outcome looks like and working backwards from there. And we want to ensure that the strategy we employ on this fire lasts longer than our team's tenure. And so I'm going to walk you through a quick overview of what we're doing with a special emphasis, again, on the Isabel Lake area. And then we're going to hear from our fire behavior analyst, and he's going to walk you through some of the science that helps explain how we do that. So hopefully you'll walk away with a better understanding of the art and the science that is strategic, long-range planning and firefighting. So we have fire here on the ridges that rise up above Isabel Lake. We have a primary indirect control line on the road system above Isabel Lake, and we have values that we're trying to protect around the lake and out past that control line, the communication tower, the homes, the structures. And what we're going to be utilizing to implement this strategy is an indirect control line, I've mentioned, on the road system in coordination with slow, methodical firing operations. To initiate fire on a landscape this big and to do so in a slow and methodical way, we have a lot of tools at our disposal. One of those that has been particularly helpful on this incident is our drones, uncrewed aerial systems, and they can actually initiate small fires with the drone in places that people can't walk. And I won't get into too much of the minutia of that. Rick's going to do a great job painting the picture for how we do that. But ultimately, I want to answer the question, why? And we're doing that to ensure that we're protecting the values, that we're containing the fire within our primary indirect control line, and we're being very methodical in how we apply fire to the landscape. I've mentioned before on previous updates that one of our watchouts is unburned fuel between us and the fire. And so if you'll see, we have that exact scenario set up here. Even after the recent rain, we have to be thinking about unburned fuel between the fire and our control line. This country is too steep. There are too many hazards like dead standing trees that can strike firefighters, and so we're unable to go in and chase that fire's edge and pick it up directly. So we're going to fall back to that indirect line, and we're going to use drones to time and apply fire on high ground, allowing it to trickle downhill, and that really should enable us to create a robust control feature up high, as well as protecting our values down low. So let's take a listen to Rick and see what he has for us to help explain some of the how that we do this. And I hope that this is helping paint the picture so all of you can better understand what we're doing and what we're preparing to hand off to the next team, because this is going to be a long, methodical process. It certainly will not happen overnight. Thank you.
Hello, my name is Rick Connell. I'm a fire behavior analyst with Team 6. Here to talk to you a little bit about how fire activity has occurred and may occur in the future, which is the job of the fire behavior analyst, is to figure out where the fire might go, when it might go there, and how it might get there, and what that impact is to not only the firefighters, but values at risk and in people as well. So here's the image of how the fire was Tuesday morning after a big active day. We had a run up this gully here that took out quite a bit of terrain and then slopped up onto the top of the ridge, as well as over here on St. Charles Peak, fingered out across the road, but we had a secondary containment line behind it that is currently holding it. And as we've looked at this from a fire behavior point of view, we've got steep terrain, we've got pretty dense fuels as far as overstory, we've got mixed conifer in the lower and mid elevations, and solid spruce across the top. Spruce is a very on and off timber type. It takes a lot of heat to get spruce to burn, but when it does get it, it burns like gasoline. Thus, when this piece went off, put up a big column several days ago. So from the fire behavior point of view, we start looking at what can we do about the fire, about protecting our primary value at risk, which is homes and structures along the 165 corridor in the Lake Isabel area. So the first thing we kind of looked at is, well, where are we going to kind of have holding features that firefighters have a pretty good chance to to hold a fire. And basically in the middle of the fire, there's not a lot of terrain or access in there, and there is no way to get people in and out safely. So we look at the bottom of the fire and put some opportunities where we think we might be able to hold the line. Go to the next slide. So not necessarily exactly where it's going to be, but something along the lines of going around the community and tying back into the fire is what the plan would be. The line may change operationally. And then we start saying, well, that can catch the bottom, but if you light the bottom, the fire could run to the top, and we need to kind of contain the top of the fire before we really want a lot of heat going north, which is what we've been working on for the last couple of weeks. So along the top, the next slide, we did some modeling along a line that could be utilized by firefighters that we've already started establishing fuel breaks along, connecting meadows, etc. And you can see it in here in this white buffer around the roads is a model data set for a one-day event that we would look at if we could ignite that fire, that perimeter in some kind of fashion. We wouldn't necessarily do it all at once, depending on what the current situation is, but this kind of gives everybody an idea of what the fire might do. And again, over in this spruce, it's probably over predicting how much fire would come down in a day, given the fact that there's less fuel on the ground. But it also shows a few places where spotting might go over the road, which is good for firefighters to know that ahead of time, because that way they can focus on those areas as they're patrolling and monitoring as we light the fire in these different places as we need to. Next slide. This model is a multi-day run if we burn out around the community of Lake Isabel, and gives us an idea of if fire is coming down the slope towards Isabel, when can we maybe start ignition and how long it might take to get there. Depending on the conditions, which is current conditions today, in the future, conditions could be changed and it could take longer or less time for actually the fire to make that to where this fire is coming down and they would meet. One of the concerns with this is when you put a lot of fire up in these draws and canyons is if we burn too intense, that could cause problems with flash flooding in the future when we get thunderstorms over them. So we're really looking at opportunities to bring fire down in a way that we can mitigate the high intensity fire on the landscape. We also are watching the slow movement of fire in this direction. Fire has not really moved much in the last 10 days or so, so we're not really expecting this to hook us, but fire up here and fire over here is where they could start moving across the landscape. We expect in the next 5 days or so, the weather is going to be mitigated, so this isn't an immediate threat, but it's something that we're putting the plan together, and this is the kind of information that we use and model to create the best information of what might happen under certain scenarios.